Hey everyone, and welcome back to Virtual Tutorials. In today's tutorial, we're going to unlock a fundamental aspect of visual creation inside of Blender, camera lenses. Often overlooked, the type of lens you choose dramatically impacts how your 3D world is perceived, influencing everything from realism and depth to technical accuracy and immersive experiences. We'll be diving into Blender's 3 lens types: perspective, orthographic, and panoramic. We'll not only explain what each of these lenses are, but we'll go over how an artist could or would use each of these lenses in their creative projects. Let's get started. Before we explain the various lens types, let's first go over simply how to add a camera inside of Blender. So when you're inside Blender, it's pretty easy to add a camera. Essentially all you have to do is come up here and click Add, and then you can select Add Camera. Now the camera is going to add wherever your 3D cursor is in the 3D viewport. So if you want to move the 3D cursor, you can click up here and say we move it to, say, right there, and then we can just go to Add and then add the camera. There we go. And we can see that the new camera has populated in our scene collection over here, and it's always a good idea to name your assets. So we'll call this camera tutorial. There we go. And that's how you add a camera. Now that we've added our camera, you're probably curious to see what the camera is saying. Well, as you can see, this arrow indicates that this is the top facing of the camera, and then you can tell that the camera is facing this direction. So it's probably not going to see anything, but let's see for sure. We can go to View, and then we can go to Viewport or Viewpoint, and then we can click Camera. Or if you have a number pad, you can just select 0. That's weird. I thought it wasn't seeing anything. Well, when you go to see the camera, essentially it's going to show you the camera that is the active camera. And so if we come back out by pressing numpad on a 0 or going there, we can see that it showed us something that it looked like it was coming from right here. Here we are. This is our active camera. And let's go back to making sure that we're using the select box here. This is the active camera, and you can tell the difference. You see how this triangle is filled in versus the one that we added. The triangle was hollow. And so when we go to see from the camera's perspective, we're going to only see from the active camera's perspective. So with the camera that we added, why don't we make that the active camera so we can see what it sees? You can right click here and you can select Set Active Camera, or you can press Control Numpad 0 if you're on a Mac, or Alt Numpad 0. So let's make this one the active camera. And now it does default kind of let you see what the camera sees. And as we suspected, it's just 3D nothingness. So let's get back out of that view, and by going to the viewpoint and camera or numpad 0. And now a camera can function just like any other object inside of Blender. You can rotate it, you can scale it, etc. So let's see if we can make our camera look down at the cubes below. Let's do a orthographic view from up top so we can kind of see what we're working with. And we can see that the camera on the z-axis, if we were to rotate that kind of gets us in a good place to begin with. So I do have an on-screen keyboard that I use, and it helps me. But I'm also going to tell you the keys to press. So if you want to rotate the camera, we're going to rotate around the z-axis. So we're going to press R for rotation, and we're going to make sure that we're rotating around the z-axis. And okay, that's a good perspective so far. We can see the camera's more in line with our cubes. But let's look at it from the side and see just how much it's aligned with the cubes. Well, it's not perfectly aligned with the cubes. Let's see if we can bring it over to the left a little bit. So we want to grab this and we want to move it along the Y. Perfect. And then we want to rotate it just a little bit more so it can look down at the cubes. So let's rotate this along the X axis. There we are. Okay, so far so good. Now let's look at it from the Y perspective. Okay, so from the X it looks good, from the Y it looks good. From the Z, it's still a little bit off. So let's see if we can move this over to the left just a little bit. Let's grab this. We'll move it along the X axis. Okay, now let's zoom into our camera, or let's look at our camera view and see what we see. Okay, now we can see what the camera sees, which are these cubes right here from this perspective. Let's get back out of the camera view so we can see our full scene. And I'm going to click the middle mouse to cancel out of orthographic view. That way I can navigate around my scene freely. The next aspect of a camera that I wanted to talk to you about is once you have the camera selected, either in the scene or over here in the scene collection or over here in the outliner, you can come down here and you can see it in your editor type. So down here we click on the camera, we have a lot of different options. And this is how you can adjust the settings for that camera that you have selected. And since it doesn't default to the title that you have in the outliner, it's good to go ahead and rename this one too, to make it align. It's not essential, but it's helpful. And so if we're looking at our settings for the camera, our object data properties, we come here, we twirl down lens, and the first thing we see is the type of lens. So there are 3 different types of lens. There is perspective, orthographic, and panoramic. With our cameras in the scene, let's delve into the first and most common lens type, perspective. The perspective lens is the default lens inside of Blender, and for good reason. It mimics how our own eyes, as well as most cameras, actually work. It creates a sense of depth and realism by adhering to the rules of perspective. So let's look at our first one. This is the type. So this is the one where you're gonna have realism and depth, okay? So let's just say that you're looking at these series of cubes. You can see they're all the same size, but they are getting further and further distance away from the camera. So let's select our camera here. Let's right click it and make it the active camera, okay? And it does default show us the camera view. As you can see, it's just as our eyes would see. The cubes in the distance look smaller than the cubes in the foreground, or in the cube in the foreground. And we can actually measure this. If I were to take just sort of an annotation tool, and let's make this a different color. We're gonna make this a different color so it shows up better. So we have red here. Well, you see how big that line is right there for the front facing part of the cube. And now we can see that one. And if we were to hide everything in our selection by going up here and clicking the I button for the collection, you can see that this one looks a lot bigger than this one, right? Even though it's the same exact cube. This really is the essence of perspective. And the fancy word to explain this phenomenon is called foreshortening. Now this idea of foreshortening can be a little tricky to understand because the word for and shortening, for gives the idea of something in front of or before, and then shortening is to, shorten the length of something, right? And so you might think this only applies to things that are in the foreground of an image or a video, but it doesn't deal with whether something is close to you or far away. Rather, the for is, think about it in terms of it's in front of you. So you being the observer of the picture or of the scene, anything that's in front of you that's being shortened for a particular effect to create that sense of realism and depth is kind of what the term means. And at its core, foreshortening is the phenomenon where the apparent length or depth of an object seems to compress or shorten when that object is angled directly towards or away from your viewpoint. Why does this happen? It's because our eyes, like a camera, capture the world in 2 dimensions. Think of it like a flat image on your retina or a sensor in the case of a camera. Our brain, after capturing this 2D image, then works incredibly hard to interpret that 2D information into the 3D world that we all experience. And in art, as well as in optics, foreshortening applies to any instance where an object's length along the line of sight is visually compressed due to its angle. The key is that the object is not perfectly perpendicular to your view. Let's create, for example, a cylinder of sorts. We're going to add a mesh, and we're going to create a cylinder here, okay? And then we're going to rotate it along. We're going to rotate it along the y-axis 90 degrees. So that's R, Y, and then 90. You can press that for the short key. And then let's lengthen this cylinder by scaling it along the x-axis. So S, we're going to do along the x-axis, and let's scale this outward, okay? And let's add a camera in front of it. So let's take our 3D cursor and we're going to move it to the left. Let's see how this holds up here. Move this over here. Something like that. We can also press shift and then right click to move the 3D cursor. And so now I want to add a camera here. So let's do the camera and let's go into our camera view, numpad 0. And then we forgot to make it the active camera. So let's get out of that view and we'll make this one our active camera. Right click, set active camera. There we go. And then we will actually transform it inside of the camera, because you can do this from this perspective. So I'm going to rotate this along the Z axis. So R for rotate. I'm going to constrain it to the Z axis. And there we go. Okay. So here's a good example of foreshortening. So if you can imagine that this camera is sort of like our retina, or the sensor of a camera, that it's perceiving a two-dimensional object, right? And so we can see its full length. But imagine if I were to take, once I get the selection here, imagine I were to take this and I were to rotate this a little bit along its Z axis. So we're going to rotate along the Z axis. Now there's a couple things that we can notice. Number one, the length is not as clearly perceived. We don't see the full length of this object. So that's the first thing that we notice. It almost looks compressed. And so yeah, from this perspective, you can kind of tell that the length looks shortened. And this is really the essence of foreshortening, is when something is perfectly perpendicular to your perspective, you can see its full length. But as soon as it goes off into the distance, number one, in the distance, it looks smaller than what's in the foreground, and it also looks compressed. In summary, foreshortening is a visual effect where an object's length appears compressed or squashed when it's angled into or out of your view rather than being flat perpendicular to your gaze. So your eyes capture a 2D image, and when a 3D object extends into depth, that depth gets visually flattened or shortened on that 2D plane. Foreshortening is crucial for creating realistic depth, adding drama, and conveying dynamic action in your art. It makes objects feel truly three-dimensional in space. The other aspect of the perspective lens is this idea of a converging parallel lines. So essentially imagine railroad tracks. So as the railroad track goes off into the distance, the railroad track lines appear to converge towards a vanishing point on the horizon. And this shrinking into the distance gives us a sense of depth. And so when it comes to your angle of view, this is where the focal length can come into play. A lower focal length, for example, 24 millimeters, as you can see with our camera, is going to create a wider field of view, capturing more of the scene and often leading to more dramatic perspective distortion at the edges, like a wide angle lens. And in order to show this, we'll bring our cylinder closer to the camera. Now, if we were to increase our focal length, say to 85 or even 135 millimeters, it's going to create a narrower field of view, making distant objects appear larger and compressing the perspective like a telephoto lens. And so this is actually what's happening inside the camera. And if we were to look at it from outside the camera, we can see the focal length getting bigger and bigger. The perspective lens creates believable character interactions within an environment where depth and spatial relations are crucial. And so a lower focal length creates a wider field of view, capturing more of the scene and often leading to a more dramatic perspective distortion at the edges, like this image here. Conversely, a higher focal length creates a narrower field of view, making distant objects appear larger and compressing the perspective, like this image here. Perspective lenses are important for character animation. If you're wanting to create believable character interactions within an environment where depth and spatial relations are crucial, check out this example of a close-up with a slightly blurred background. This is achieved through something called depth of field. and that's related to the aperture and focal length, which you can see here in the settings. Another use case for the perspective lens is rendering buildings and interiors that look realistic, conveying the sense of space and scale as a viewer would experience in real life. And you can see how the perspective lines guide the eye. You can see that in this image here. Another use case for the perspective lens is product design. If you're wanting to showcase a product in a way that feels tangible and allows viewers to understand its three-dimensional form within a space, like this photo here. And if you're wanting to create dynamic and dramatic shots, you can use wide-angle perspectives that exaggerate the size of foreground objects and create a sense of vastness, while telephoto perspective can isolate subjects and create a feeling of distance or intimacy. Check out some of these photos here. Now let's go back and revisit our original scene, where we have all the cubes going further and further into the distance. With the perspective camera, we saw that the ones in the distance looked like they were smaller, and that there can be compression depending on the angle of the view. From this angle, we're not going to see that because it's perfectly perpendicular to our perspective. But like we said with the cylinder, it looked like it was getting compressed as its angle changed from our view. Now let's explore the orthographic lens. This lens completely breaks away from the rules of perspective, projecting all points in the scene along parallel lines onto the image plane. This results in a flat view where objects don't appear to shrink with distance. But now let's change this from a perspective camera to an orthographic. All of a sudden, there is no depth or perspective. Every cube is the exact size that it truly is, and you can't tell which one is more in the foreground or which one is more in the distance. And the difference between the perspective view, which we saw where the parallel lines tend to converge to a single point in the distance, unlike that, as we can see here, the parallel lines don't converge at all. They remain parallel even into the distance. One setting within the orthographic lens is the orthographic scale. So this scale is going to determine how much of the scene fits within the camera's frame. So as we increase the scale, we get more and more of the scene into the frame, and as we decrease the scale, we get less. Let's look at what this looks like outside the camera from the side. As you can see here, as we increase the orthographic scale, the camera gets larger and takes in more. As it gets smaller, it becomes smaller and takes in less. This is really the architect's blueprint. So basically, for many architects, if they're looking for a direct, undistorted projection, this is the camera that they want, or this is the lens that they want to use. It's like looking at a perfectly flat technical drawing where depth isn't represented through size. This is where you're creating clear, measurable representations of objects or scenes where accurate proportions are paramount. Think of instructions, cutaway views, or schematics. Another use case for this is in what we call isometric game art. So this is rendering assets or scenes for isometric games where objects remain a consistent size regardless of their depth on the screen. And you can see some of these examples here. It certainly creates a very distinct visual style that I'm sure you are familiar with, but you didn't know that that's what was causing it. Now, another use for orthographic view is not directly tied to the camera, but it does help to explain how some 3D artists will talk about orthographic views. And so let me show you an example of that. If we're looking at our cubes here, we do get a sense of depth, right? As we zoom out, the stuff in the distance looks shorter, and that's because of the particular view that we're in. Now, if we were to change our view from perspective to orthographic, this would be orthographic. Things in the distance are the same exact size as they are in the foreground. It's helpful to think about orthographic view in terms of how we do modeling as well. So if I want to look at this from an orthographic view, I would press Y and I could see straight on everything with the Y. And as you can see, it doesn't show me any distortion as far as distance is concerned. Or if I want to come to the X, it's the same, and with the Z there as well. And this can be very helpful for achieving precise results. It eliminates the visual distortion of perspective, making precise adjustments just that much easier. So sometimes you can also use orthographic views for creating user interface elements or overlays. So sometimes there are elements that need to appear consistently sized on the screen, regardless of the 3D scene behind them. Finally, the orthographic lens is helpful for stylized, quote-unquote, flat renders. This achieves a deliberate artistic style that rejects realism in favor of a clean graphic look, like you can see here. Now notice though, however, that even though you can't tell if it's getting smaller into the distance, you can still see that there is some foreshortening that goes on. Because as we see it from here versus this angle, we can tell that that's a different length based on the perspective. But here there still is some foreshortening going on. And we'll switch this back to perspective mode. Let's go back to our camera. Let's make it the active camera. And then what we'll do is we will change the type of camera that it is. Finally, let's explore the panoramic lens. This is a special type of lens designed to capture an extremely wide field of view, often encompassing a full 360 degrees or more. Also, we need to change our to be perspective. There we go. And we'll go to our final camera, which is the panoramic camera. So let's see what we see inside of here just from the default view. Okay, it looks very similar to what we might see with the perspective view. It seems to get smaller in the distance, and there would be foreshortening going on. Okay, the first thing to notice with this panoramic camera, it looks just like our other one, right? The thing that we have to do, and let's turn up our lighting a little bit in the scene. Okay, so we've got this in rendered mode, and what we want to do here in order for this to work is we actually have to change the render engine from Eevee to cycles. And then with cycles, we'll be able to actually use the panoramic camera. And now let's see what our perspective of the camera is. Or let's see from the camera's perspective what we're looking at. As you can see now, let's go to our camera settings here. You have different settings for the panorama lens, okay? So as we look at our cubes here, they don't look that different than it would say from a perspective lens, but that's probably because they're more closer to the center. But if we were to bring the camera a little closer, so let's do that, and let's go back and see that perspective. It's starting to get a little more distorted because it's getting closer to the edges. Let's bring it just a little bit closer, and we can do that actually while we're still in the camera mode. So let's grab that, and we're going to move this closer using the Y mode. Okay. So as you can kind of see, as it gets closer to the side, there's more distortion with it. And that's the idea of the panoramic lens, is it's trying to gather as much information in the immersive world as it possibly can. And there's different types. So for example, the most common type that you're going to see is the equirectangular. This is the one that's most commonly used for 360 degree panoramas and virtual reality. So it unwraps the spherical view onto a flat 2D image, as you can see here. And this does result in a significant distortion, especially towards the top and the bottom. But this distortion is correct for viewing in 360 degree viewers or VR headsets. And you can see some examples here. And if we were to take this equirectangular and let's zoom in on our camera just a little bit more, you can see how it really starts to distort our cubes, right? Now, the next one that I want to look at is the fisheye. And this is a very common option for these cameras. So it creates a circular image with extreme wide angle distortion, and it's used for artistic effect or capturing a very wide view in photography. So let's see what this looks like inside of the viewport. This particular fisheye is more of an oval, so you're going to get a more oval distortion. This Equisolid fisheye is going to give you more of a circular distortion as opposed to so much of an oval one. And let's see if we can move our camera back just a little bit by pressing G and bringing it back along the Y-axis. There we go. And as you can see, as it gets closer to the edges is when the more and more of the distortion occurs. This last one that I wanted to show you is the mirror ball. I'm sure you might have seen these at various places as you've been, I remember seeing one in Washington, D.C. at one of the gardens there. But essentially, this simulates the reflection in a perfectly spherical mirror. And it looks pretty cool for some great artistic effect. And again, remember that the panoramic camera is only going, or the panoramic lens is only going to work inside of the Cycles render engine. And as I mentioned before, the most common panorama type for 360-degree images or virtual reality applications is going to be your equirectangular. And with this one, the most important thing to remember is you need to have a 2-to-1 aspect ratio for these equirectangular renders. That is, you want the width to be twice the height to get a full 360 by 180 degree panorama. Thus, if you want a really large resolution, say a 4000 for the X, you're also going to want to make sure that your Y has the half of whatever the width is. So in our case, we did 4000, and as you can see, it didn't really change anything. So another example would be, say you have 8000. What would you want to make your Y? That is your height. You would want to make this 4000. And you can see it reflected in the size of the camera. The most common use cases for the panoramic camera lens is going to be creating virtual reality content. So rendering equirectangular panoramas can be viewed in VR headsets, allowing viewers to look in all directions within their 3D space. And you can see some of those examples here. Another option is generating 360-degree panoramas for web or presentation. So you can create interactive panoramic images that users can pan and zoom within. How cool is that? And you can see some examples here. Still another is creating HDRI environment maps. HDRI environment maps. HDRI stands for High Dynamic Range Image. And these essentially is where you create high resolution equirectangular panoramas to use as environment lighting in your scenes. And it provides realistic reflections and ambient light. And you can see some examples here. Another use case is for artistic and abstract effects. Using the extreme distortion of fisheye or the unique reflection of mirror ball for creative and unusual visual styles. You can see some of these stylized examples here. Finally, the panoramic lens can be used to capture extremely wide shots. These are situations where you might need to see as much of the environment as possible in a single render. So, with these 3 different lenses in your toolkit, how do you know which one to choose? It all comes down to your artistic intention and the needs of your specific project. For example, if realism and depth is what you're looking for, perspective is going to be your best choice. If precision and technical accuracy or a stylized flat look is what you're looking for, reach for the orthographic. If an immersive 360-degree experience or unique distortions is what you're going for, panoramic is the way to go, and make sure to use Cycles for that. And don't be afraid to experiment. Create a simple scene and render it with each of the different lens types and see how dramatically the view changes. Understanding these fundamental camera properties will give you greater control over the final look and feel of your 3D artwork. And if you enjoyed this tutorial, well, my name is Elijah and I am a professional Blender teacher, and I would be happy to work with you in a one-on-one setting at a very reasonable price. You can reach me at virtualtutorials123@gmail.com, and that email is in the description. Always remember, whenever you're learning a new skill, remember the 4 P's: passion, patience, pace, and perseverance. Thanks for watching. I'll see you in the next one.